So today we will discuss about communication system. Okay. So it's more theoretical in nature, but it is important to understand the concept. Okay. Because nowadays knowing about communication system is so important. Okay. So uh, basically, like the what we are going to discuss about like how do we transmit a signal from one place to another. Okay. So uh, so what are the different components of a communication system? Okay. You will have a transmitter, and then you will have a receiver, and it will pass to some channel, whatever. What are the different components of a communication system? Okay. So there are some certain terminology related to associated with communication system, that also we will discuss. Okay. So uh, basically, the if we see a communication system, if I draw the block diagram of a communication system, so you will have a transmitter. Okay. You have studied, no? Right?
Yeah.
So you will have a transmitter. You will have a transmitter. Okay. And then you have a channel. Okay. And then you will have a receiver. Okay. So you will have a so you have a transmitter, you have a receiver. Okay. And you have a channel, and the transmitter sends the, we call it as transmitted signal. Transmitted signal. Okay. And then the receiver, here it is called received signal. Okay. So in a communication system, you have a transmitter, you have a receiver. Okay. And then before transmitter, you will have some information source. Okay. So this is some information source. So this is your information source, and this is called your message signal. Message signal. Okay. Then there are chances that some noise can get added to this channel. Some noise. Okay. Okay. Then uh, a receiver, from receiver it will get processed, and again you will get some message signal and you will receive. Okay. So like say I have somebody here. Okay. And again it is like, I would say, okay, so again it is like information source, and then it is user information. Okay. And then this is again message signal, it again gets converted to message signal. So just imagine that this is a your voice. Okay. So your voice, whatever you are talking, okay, it is basically a sound or a pressure wave. Okay.
Yeah.
So this pressure wave gets converted into a electrical signal. Okay.
Okay.
So you know there is a device called your microphone.
Yeah.
Okay. So what does microphone does?
Okay.
Microphone converts your this pressure signal, this vibration into a electrical signal. Okay. So that electrical signal. Suppose I am standing near you. Okay. So if uh, if these two persons are standing near each other. Okay. We don't when these two persons are standing near each other, we don't need all these transmitter receiver. You are talking, this person is listening.
Yeah.
Okay, but when you are you want to transmit the signal to a very far place, you
You
need
need all.
all these things. Okay,
Yeah.
so you have the information source. Suppose you want to transmit your voice. Okay? Let us say, for example, you have telephones. Okay, so telephones you are talking here. So basically it is a sound pressure wave. Okay, so this pressure wave gets converted to the microphone converts it into a kind of microphone or whatever. It is getting converted into a electrical signal. Okay, so that electrical signal is transmitted to the receiver. Okay, so what happens in between and all that. Okay,
Yeah.
and so basically uh, the basic modes of communications are broadly divided into two. Okay, so basic modes of communication. Okay. What are the basic modes of communication? What are those two? Okay. One is point to point. Okay. Point to point. Point to point. Okay. And another is broadcasting. Broadcast. Okay. So this point to point is your telephone. Okay. I am talking from here, someone is listening there. So from one point to another point, that is point to point communication. But broadcasting is like your radio or television or whatever. Okay. So whatever, like say in the TV station or radio station, somebody is you are conducting the program, whether it is the sound or whether it is the visuals or whatever. There, this signal is being sent to say through satellite communication. So it goes to the whatever you are talking, it goes to the satellite,
Yeah.
and the satellite sends it to multiple location. There, somebody, the news anchor is talking, so his visuals or his sound is going to the satellite, and from satellite
Yeah,
to
radio.
thousands of television or thousands of radio, it is being
Transmit.
that signal is coming. So that is called broadcasting. So TV, radio, and all those are called broadcasting.
Broadcast.
But point to point is
One
your
person.
telephone. Okay. So your telephony is point to point. Telephony. Whereas your TV, radio, these are all broadcasting. Okay. These are two major. These are the two major basic modes of communication. One is point to point, and another is broadcasting. Okay, and what are the different components of a communication system? Major is your transmitter, receiver, and then this is information source. This is the information that you receive at the end. Okay, so in communication system, the transmitter is located at one place, the receiver is located at some other place. Okay, so it can be very far off place or whatever. Okay, so depending on the type of communication system, the channel may be in the form of wires or cables connecting the transmitter and the receiver, or it may be wireless. So this channel, what do you mean by channel? So this channel, whatever electrical signal you have got, okay, from the transmitter, whatever electrical signal you got, this channel means it can be wired or it can be wireless also. So earlier it was wired communication, that electrical signal used to get transmitted using wired communication, and with the advanced one we have wireless communication also. Okay, so the purpose of transmitter is the purpose of transmitter is to convert the message signal. The purpose of transmitter is to convert uh, message signal produced by the source of information into suitable form of transmission through the channel. Okay, so the transmitter, what does it do? It convert the message signal produced by source into, this transmitter, what does it do? It converts the message signal so that it can be transmitted. Okay, so that the transmitter convert message signal. So you are getting a message signal. That message signal produced by the source into a form of suitable transmission through the channel. So it will convert it into a electrical signal. Okay, this transmitter. Okay. Uh, so the output of the information source is a non-electrical signal like a voice signal. So finally you will get a voice signal. So you are giving a voice signal, converting it to electrical, and at the end again that electrical will get converted into a voice signal again. Okay, so converting the voice signal into electrical signal, and at the end again converting that electrical signal into the voice signal. Okay, that will happen at the receiver end. Okay, so the output of the information source, the output of the information source is non-electrical signal like a vibration, and a transducer converts it into electrical form before giving it an input to the transmitter. So, yeah, there is a correction here. Before it comes to the transmitter, it is getting converted to an electrical signal.
Okay.
Okay. So that
From information source. Right?
from information source, it gets converted to electrical signal. Okay. Now, when a transmitted signal propagates along the channel, it may get distorted due to channel imperfection and noise. Okay. Okay. So the receiver has the task of operating on the received signal. It reconstructs a recognizable form of original message signal for delivering to the user information. Okay. So there are two types. What I have told. Okay.
Yeah.
One is point to point. One is broadcast.
Broadcast.
So here the voice signal is getting converted to electrical one.
Signal.
Okay. So yeah. So you take a picture. We'll go to some of the terminology related to communication system. So there is something called transducer. So what is a transducer? Transducer. Okay. So a device that converts one form of energy into another form is called a transducer. Okay. So for example, you have the microphone. Okay. Microphone is a transducer. Okay. What it does, it converts your sound, or you can say converts physical variable. Okay. So it converts physical variable. Okay. Variable like pressure. Okay. Variable like pressure. Okay. It converts physical variable like pressure, temperature, force, displacement into corresponding electrical signal. Like pressure into corresponding
Electrical.
uh, corresponding electrical signal. So your example is your microphone. It converts your, so your sound is nothing but your pressure variation. We have studied it in your physics.
Yeah.
Sound is nothing but your variation of pressure. Okay, pressure variation. Okay, and that is a longitudinal wave. Longitudinal wave and transverse wave you have studied.
Yeah.
So it's nothing but your pressure variation, and this pressure variation using a transducer, it gets converted to a electrical signal. Okay, electrical signal. Okay.
Yeah.
So that is a transducer. Okay, then what is a signal? Signal. We have converted it into a electrical signal. So they are selling signal. Signal is information converted in electrical form and suitable for transmission. Okay. So signal is information converted in electrical form suitable for transmission. So this is called a signal. Okay. So here information can be your voice, your sound. Okay, this is your sound, your audio signal. We say the audio signal.
Yeah.
So you want to convert that audio into a electrical signal, and then using transmitter and the your wired channel or whatever, you send it to the receiver end. Okay. So this is a signal, and in communication system there are two types of signal. One is analog, and another is digital. Okay. So this digital is a binary thing. Okay. So high, low. So those kind of things. So the digital can be like say either 0, 1, 0, 1
Yeah.
kind of. Okay. So this is digital.
Yes.
Whereas analog is a continuous value. So this is analog signal. Okay. So analog signals are continuous variation of voltage and current. So let us say I am saying that it is a electrical signal. Means it can be electrical voltage or electrical current or whatever. So with respect to time, if my voltage or current, which is the electrical signal, it varies continuously, it is an analog signal. But with respect to time, if it is either 1 or it is either 0, then this is a digital signal. Okay. So this is we have discussed about transducer, we have discussed about signal. Okay. Then I was talking about noise. Okay. Noise means when you are you want to transmit a signal. Okay. But suppose I just want what I am talking to you, talking is should go to you. But there can be some unwanted noise which can mix up with it. We should try to avoid. We should try to isolate our this noise, our system from this noise. Okay. So noise refers to an unwanted signal. Okay. That tend to disturb the transmission. Okay. So processing of message signal in a communication system. So we should filter out all those noise. Okay. Okay. Then that is noise. Okay. So then there is transmitter, receiver, and all these things. Okay. So you take a picture. We will discuss what is a transmitter, what is a receiver. Understood now? What is the analog, what is digital?
Yeah.
Because in electronics there is a big chapter, one particular subject on digital electronics. Okay. Okay. Then transmitter and all what I have discussed. Like I have a transmitter, I have a channel, and I have a receiver. Right? Transmitter, channel, and I have a receiver, right? So these are the three major things. Okay. So this channel can be wired or wireless or whatever, wired or wireless or okay. So this is my transmitter, right? This is my receiver. So what is a transmitter? A transmitter process the incoming message signal so as to make it suitable for transmission through a channel and subsequent reception. So what does transmitter do? So before transmitter, it has already converted into a electrical signal, right? Before transmission. So what does transmitter do? Transmitter, actually there is something called modulation. Okay, so this electrical signal will have so this whatever we see na, this electrical signal, its frequency will be very
Continuous.
no, it's continuous, but its frequency is very less. Okay, so this frequency is very less. So for transmitting a signal, its frequency has to be very high. You cannot transmit
A low
low
frequency.
frequency signal. You can transmit only a high frequency signal. So this is called like say base signal. Okay, so this electrical signal is base signal. Okay.
That is again converted to high frequency.
That is superimposed with a high frequency carrier signal. Carrier signal.
Then it will become a high frequency.
So this is base signal. This is carrier signal. Carrier signal. So these two things are superimposed. Okay. So that you will have a modulated output, which will have very high frequency. So so the distance traveled. So the distance traveled depends on is directly proportional to frequency. Okay, so if you can increase the frequency of, it will have base signal along with carrier. If you superimpose, you will have a modulated wave. So this is base wave, this is carrier signal. When you superimpose, add both the things, it will become a modulated wave. So that will have a high frequency, so it can travel longer distance. Okay, so that work transmitter does that work. Okay, so that's why they are saying a transmission process the incoming signal to make it suitable for transmission. So what does a transmitter do? It process incoming signal so that it can be easily transmitted. That is the job of a transmitter. Okay, then what is the job of a receiver? Okay, a receiver extract the desired message signal from the received signal at the channel output. See, this is what we have sent. So this is what we want at the end also.
Yeah.
So what you are talking in a telephone, the other person should hear that only.
Not with the high frequency.
So we are adding this carrier wave only to
for the transmission.
Only to transmit it. So at the end, receiver from the modulated wave,
again
it
convert
will
it
again
back to base signal.
Base signal. So the analogy is like this. Suppose you have a paper and you have a stone. Okay. So you imagine that my carrier wave is nothing but a stone. Okay. And you imagine that my base signal is nothing but a paper. Okay. So you try to throw the paper. You cannot throw. But if you wrap that paper around a stone and try to throw, it will easily go. So that is why that is the analogy. Okay.
But at the end you will get.
At the end you need the paper only, not the stone. Okay. So that's what the receiver again process the modulator
and only transmits the base signal.
Yes. So it will receive from the modulated wave. It will extract the base signal and you will receive that.
Yeah.
Okay.
Understood.
So this process of mixing base signal with carrier signal is called modulation.
Done by transmitter.
So modulation, there are three types of modulation. Okay. So modulation, one is amplitude modulation, frequency modulation and phase modulation. So three type of modulation. Okay. So this the difference between this base signal and this carrier signal is that this base signal, its frequency and amplitude, everything can vary. Whereas in case of a carrier signal, it will have a constant frequency and constant amplitude. That is the difference between base signal. Because whatever you are telling, you cannot have a control over it, but you can have a control over this. Okay. So there are three different types of signals. Modulation. One is amplitude modulation, one is frequency modulation, one is phase modulation. Phase modulation. Okay. So okay. So this is transmitter, receiver, and okay. So and what are the different advantages of modulation? Okay. So there are some. So modulation helps in long distance transmission. Okay. So you can transmit your signal or whatever audio signal or whatever signal for very long distance. So that is a major advantage of modulation. Okay. And another advantage, I will do one numerical and show you what is the another advantage of modulation. Because when the frequency increases, the size of the antenna will decrease. Okay. When the frequency
proportional.
When the frequency increases, the wavelength decreases. When the size of the antenna is nothing but lambda by 4.
Yeah.
Okay. We will take one example and tell. Suppose when the frequency of the frequency increases, okay, that implies the wavelength of that electromagnetic wave decreases. Okay. So the size of antenna is typically lambda by 4. Okay. So so if your frequency is very high, your wavelength will be less, and correspondingly your antenna height will be less. But if your frequency is less, your wavelength is high, and you will end up with a antenna of size 10 kilometer and all. So we'll take one example and I will explain. Okay. So the advantage of modulation is because you are increasing the frequency, the size of antenna can be decreased, and it can be transmitted over long distance because distance traveled is proportional to frequency. Okay. And also another advantage is, suppose you are talking at a less frequency. You are talking, let us say whatever we are talking. Okay, so our frequency varies from 20 Hz to 20 kilohertz. Okay, 20 Hz to 20 kilohertz. This is our audible range. So when you are talking and I am talking, there are chances that it will get mixed up. But if you modulate it and you mix this with a carrier wave, some carrier wave, and you make it, let us say you can make it say 81 megahertz. Okay, 81 megahertz. Okay, so you modulate it and you have increased the frequency of this modulated wave to 81 megahertz. Okay, and this 20 kilohertz again you have modulated and you have converted into 91 megahertz. Okay, so when you converted into two different frequency, there is no chance of mixing. Okay, suppose you have someone talking here, someone talking here. Okay, so this is 20 kilohertz, 20 hertz, and this is, let us say, 20 kilohertz. So there are chances of so these two getting mixed.
Yeah.
So so if you modulate it and convert it into say 80 megahertz,
Okay.
you increase the frequency, and you modulate it and convert it into 90 megahertz. Okay, so
Reduce.
so when these two people, two radio stations, you imagine. So this radio station is given, like say you have a radio station called Kotak, you have a radio station called New Delhi. Okay, so Kotak is given like say 80 megahertz as its bandwidth. Say it is given 75 to 80 megahertz. You can operate in this. New Delhi is given a bandwidth. Okay,
So they do not interfere with each other.
you are given 85 to 95 megahertz.
You cannot operate.
So there is no chance of mixing of the signal. So by doing this modulation or mixing it with the carrier wave, you can assign different bandwidth for different operators.
Otherwise, there will be mixing and signal.
Yes, for example, you have say Republic TV or you have NDTV. So they might have been assigned different bandwidth. Every channel person, whatever he has to purchase that bandwidth.
Okay.
Okay, so so they say that they are selling, say, 2G spectrum, 3G spectrum. Spectrum means what? They are being
That bandwidth,
a
in
particular
what they can
bandwidth they
offer.
have to purchase so that there is no interference with any other. Okay, so these are some of the advantages of modulation. Okay, you can by mixing it with a carrier wave, you can increase the frequency so that it can travel long distance. That is one advantage. Second advantage is that you can assign by adding to the carrier wave, you can assign a particular bandwidth for different service provider or the different channels so that there is no interference. And the size of the antenna, you are increasing the frequency, so the wavelength is decreasing, so size of the antenna also can be reduced. Okay. Okay, so we can take a picture, then we'll do one. So this paper and stone analogy will make you understand clearly why we need modulation. Okay, why we need modulation, and there are, just remember, there are three types of modulation: amplitude modulation, frequency modulation, and phase modulation. Okay.
Yeah.
So in amplitude modulation, the amplitude will depend on the base signal amplitude. Okay, so amplitude will vary. In frequency modulation, frequency will vary.
And phase modulation.
Yeah. So there are other terminology, something called amplification. So it is there is something called attenuation. So attenuation is loss of strength of signal. So suppose I am sending a signal. So it after a particular distance, say I am talking from here. I send a signal using some transmitter. Okay, so after 2 km, 3 km, the signal strength will decrease. So with distance, the strength of the signal decrease. So the loss of strength of signal while propagating through a medium is known as attenuation. So it is transmitting through the air or whatever. So after a particular distance, it will lose its strength. That is called attenuation. Then there is something called amplification. So you know this you might have studied amplification, transistor as an amplifier.
Yeah,
you have studied transistor, and transistor can behave as a diode, a transistor can behave as a switch, it can behave as an amplification. So amplification is suppose the voltage level can be increased. So if you have a certain amplitude of the voltage, it can be increased. Okay. So amplification is done at place between source and destination, wherever signal strengths become weaker than the required strength. So if the signal strength is decreasing, you can use this transistor and you can amplify it. The amplifiers also are used in communication system. Okay. Then the range. So range is the largest distance between source and the destination. Okay. Up to which the signal is received with sufficient strength. Okay. So what range it can your communication system.
On which it is transmitted.
Yeah. So and then bandwidth. So bandwidth refers to the frequency range over which an equipment operates or portion of signal occupied by a signal. So you will be, every operator will be given a particular bandwidth. Okay. So in that bandwidth they can operate. Okay. So I remember when we were kids, like we used to listen to radio a lot. Okay. So they will before broadcasting, before the news, they will say we are talking from, like say, Akashvani Kotak, our wavelength is this and our frequency is this. Okay. Similarly, when there will be national news in Odia, they will say we are operating at this frequency, some megahertz they will say, and wavelength. So any electromagnetic wave will have a frequency and a wavelength. Okay. So they are assigned to operate in that. Suppose when you are listening the FM, what you are doing, you are just changing the frequency or wavelength so that in that particular frequency you are able to listen to a particular channel, right? Okay. Then modulation, I have already explained you. The original low frequency message cannot be transmitted to long distance. Therefore, you need to mix it with a carrier wave. That is modulation. Then demodulation is extracting the base signal in the receiver. Okay. So these are some of the important terminology related to communication. Okay. Then some important things like what are the different frequency band. Okay. So you will have AM broadcast, AM broadcast,